Welcome Gershom and Dalen, Bandile, Twanelo, Sino, Arson. Welcome back, guys. Good to see you today. How are you?
Oh, I recognize lots of names. Welcome Sino and Dalen and Bandile. There we go.
Sino, we normally see your face. Where are you today? Twanelo, we're so happy that you're good. We are also well, thank you. It's a bit warm today. I'm not sure how the weather are there by you guys, but I feel it feels like proper summer today here where I'm at.
Yeah, it was hot also. Yeah.
Oh really? That's maybe
And also
why
the
your
days are
screen
getting
turned
much longer.
blue. Make it a bit
My
cooler.
screen turned blue. Maybe. I notice how much longer the days are getting now. I don't know if it's like that in Joburg, but in Cape Town, the days are getting a lot longer now. That's nice because there's a bit of extra time in the evening.
Do you find yourself sleeping later and waking up earlier, Peter?
I am definitely waking up earlier because of the light, so it comes in, earlier. And yeah, and also like I feel more encouraged to kind of go out and do something in the evening because it just feels like the day hasn't quite finished. Like there's. So I love it. I love the longer day. That's very nice.
Oh, that's awesome. Hi, Lutando.
So,
welcome.
Everyone, you know the drill by now. I think I don't see anybody new at the moment. I might be wrong, so apologies if there is, but you know the drill. So question number 1 is what you guys are doing while we wait. And then question number 2, I want you to get going with that while we still carry on welcoming everyone to our class today. This is the second lesson in a 4-unit course. And today's focus is on area. Last unit was on perimeter. Okay, so just to let you know, that's in case you've forgotten from when did I see you guys? On Monday. Yeah.
Yes. Welcome, Kuketso.
Okay.
Do you have a friend with you?
Yeah, give us some emojis in the chat there. How is everyone feeling? We want to know, are you feeling hot, cold, happy, sad? What is your, what are you feeling?
On this side, definitely hot.
Happy. Happy. That's good to hear. That is good to hear.
Twanelo also looks happy. Thanks for sharing, Twanelo. Kuketso, how are you guys? How are you today? How are you feeling?
We're feeling good.
Feeling good, feeling strong, feeling positive.
Yes, I am.
That's great. Is it a friend that's with you?
No, it's my mom.
It's your mom. Hello, Kuketso's mom. Welcome.
Thank you.
We hope you enjoy the lesson as well today.
Okay.
I hope so too.
So just to remind everyone about question 1 while we wait, the first lesson focused on this idea of perimeter. And so we're just actually starting with a bit of a recap of that. And I'd love for you to give these 2 questions a go while we wait for the others. And in fact, I'm even going to make that A, B, C, and D. And I'm going to make this question's answer A, B, C, and D. And I'd love for you to put in the chat what you think the answer is. So maybe you think it's 1A or 1B. I want to see some decision making on your part. And I'll give you a little hint. When we deal with the circle, there was a formula we discussed in the last lesson, which said if we take the diameter and we times it by a number called pi, we get the circumference of a circle, or the perimeter of a circle. So, that's just a little hint, but let's see what you can do with that for those first two questions.
Awesome. Peter, I'm going to say cheers till we see a bit later.
Fantastic.
You guys must enjoy. And remember, if you have any questions, unmute yourself or put it in the chat. Otherwise, just be sure to stay muted. Yeah, just for respecting the others as well.
Fantastic.
Okay,
Yeah. Just shout if there's anything which needs to be zoomed in or something I'm not seeing in the chat, but I'm getting pretty good now. So hopefully I'll be good for that. Okay. I see some answers coming in. For one, I'd like some other people. Sino, I see your answer. Rutando, I see your answer. Let's have a couple of others. So for perimeter, we're going around the outside. And the outside is going to be 3, 3, 3, and 3, which indeed means it's 12 units, or B is the first one's answer. So 1B, you're spot on. Now, just to point out the difference, like a foreshadowing for today's lesson, is if I'd asked you for not the perimeter, I'd asked you for the area, this question's answer would have been 9, because there are not 3 times 3 is 9, or 9 blocks inside, 9 square blocks. But that's not what the question asked, but I'm just kind of pointing that out. Okay, on to question 2. How do we use this? How do we use this formula? And remember, we're asking for the perimeter of a semicircle. So we have perimeter is like the fencing around the outside. So essentially, we want to find that. Okay, I see some answers coming in. Fantastic. A lot of people are saying A. So the main idea is that basically you need to find the perimeter is going to definitely be 7.2 plus whatever this thing over here is. And that's half a circumference. So to find the circumference, we need to go diameter times pi. So 7.2 times by pi, and that would be a full circumference. But we only want half of that. So we are going to divide this by 2 or times it by a half. And there's different ways of getting this. You can even use your calculator for it. And also there's different variations of pi. Sometimes we say the question normally specifies. I'll use 3.14 just for this question. So divided by 2. So that's plus 11.304. And so if I add that together, plus 7.2, we get 18.5, which is what everyone got. Well done, guys. I think I'll give you a shout out there. You've done nicely, and clearly we can move on from that question. Okay. I want to see, these are from other questions in the sort of exit ticket questions from the previous, at the end of the lesson, I give you a practice exercise. These are 2 of the tougher ones from that. And I want you to try and do these ones. So we'll call this question 3, and we'll call this question 4, and we'll use the A, B, C, D, and I want you to try and answer these ones as well. So we're still looking at perimeter, but the questions are a little bit harder now. We're taking it up a notch. And if you can't see, just let me know if I need to enlarge the size of the... Okay, so in this question, the perimeter, what does this look like? It reminds me of something, this shape. Where have you seen this shape before? Oh. So we're going to work out if we had to go all the way around this. So I think it looks a lot like an athletics track to me, doesn't it? You know, like when you run around the 400 meters, or maybe you watch the Olympics. And this looks a lot like that. Now, if we think about what's going on, there's actually two shapes we need to worry about, or I think we need to worry about this and this. And then we need to worry about these two bits on the end. Maybe I should even draw them a different color. So we need to worry about that bit and that bit. Now, in calculating my perimeter, I see some answers coming in. Please let the answers keep coming. I know that 4 plus 4 is definitely going to be involved. And in some ways, these ones over here are actually two half circles, which means actually it's just one whole circle in total. And so we are going to have, this thing is the diameter. And so to find the perimeter of a whole circle, we're just going to say, what was the formula again? It was diameter times by pi. Now, if I divide it by 2, I'll get the half circle. But remember, there's two half circles together. So then all we need to do is go, okay, well, the 4 and 4 is 8. And the 4 times pi, I think the question said use 3.14 times 4. We get 12.56. And together we get 20.56. So the answer is going to be A. Yep, it's A over there. Well done, everyone. And then, are there any questions about 3? Okay, I see some answers coming in for 4. So you've received a bronze medal, and this bronze medal is a circle, and the radius is 2.5 centimeters. And what's the diameter? I think that's kind of an easy one here, because diameter and radius have a very distinct relationship. So the diameter is the line that starts at the circumference and goes through the middle and goes to the other side and is straight. The radius is just the bit that comes from the middle to the edge. So I'm kind of giving it away. If you look at the drawing here, there's two radiuses in a diameter. So you can either say r plus r, or you could say 2r. And so if one of the r's is 2.5, then two of the r's must be 5. So the answer is B. Okay, I think we're ready to move on. Any questions or comments? If you're feeling comfortable with perimeter, give me a thumbs up. If you feel a little bit, give me a thumbs down. Just want to get a feel for you guys. Okay, fantastic. So let us move along. Okay, so let's talk about this thing called area. And area is different to perimeter in that we're no longer thinking of fencing. You know, with perimeter, we're thinking how much stuff do we need to put a fence around the outside of shape. Now we're interested in how much space does a shape enclose or take up. So maybe it's like thinking about, if you think about the farmer problem, initially the farmer has to fence off their land, and then the farmer has to think, well, how much space do I have to grow stuff on? And when we talk about perimeter, we talk about the basic units being units of length or one-dimensional units. But when we talk about area, we talk about two-dimensional units, or a shape that has 2 dimensions. And so we're using the humble square to measure area. And we ask ourselves, how many squares will fit into a particular enclosed shape? So I want you to think about what is the area of the figure A? And I'm going to say the area of figure A is going to be 1. The area in figure B is going to be 4 units. The area in figure C is going to be 1, 2, 3, 1, 2, 3. So it's going to be 9. So the way we would write this is we write 1 unit squared, 4 units squared, and then 9 units squared. And the reason we say squares is literally 9 little 1x1 squares will fit inside this block. Okay, now what you notice is that because of the way that things are laid out, you could count from 1 to 9 each time, or you could count every block manually. But if you have a square or rectangular shape like this, what you can do as a shortcut is go, well, how many rows are there? So 1, 2, 3. So there's 3 rows. How many columns are there? 1, 2, 3. And then just say, well, what is 3 times 3? It's going to be 9 units squared. Or sometimes if it was centimeters, we write it like that. So whenever we have rectangular shapes, a quick shortcut is not to count every block individually, but to multiply the length and the breadth, or the dimensions. Okay, just to make sure you understand this basic idea, I want you to give me an answer for D, E, and F. I want you to write how many units of area fit in D, how many fit in E, how many fit in F, and put it in the chat, please. Okay, I see D is coming through. That's good. Okay, you guys have got D. Absolutely. It's 2 units. E is 3 units. I agree. What about F? Okay, you guys are on form today. And I should actually say units squared here. So just to show you, in this case, it's 3 times 1. In this case, it's 2 times 1. And in this case, it's 3 times 2 as the shortcuts. Okay, so we've got the basic idea of area, and that's all good. Now, I don't want to, okay. How many of you, sometimes formulas can be a bit like, ugh. How many of you have seen these formulas before? So often students are taught these formulas. They don't always know where they come from. But if you've seen them before or have used them before, give me a thumbs up. And if you haven't, well, give me a happy face. If you haven't seen them before, give me a thumbs down or unhappy face. Okay, so you have seen the basic formulas before. Because when we, okay, so, and don't be afraid, please be honest here. If you haven't seen these formulas before, or at least heard of them, give me a thumbs down just so I know what I'm dealing with. Okay, so the very first formula, you'll see that the word height comes in a lot, base and height. Now, sometimes I would just say for this, length times breadth, but the more technical word is base times height, because later on, you'll see the word base comes up in every single shape. And so they're trying to be, okay, well, except for the trapezium, but they're trying to be, well, actually, not in this one either, but they're trying to be consistent in their terminology. And normally the base and the height are perpendicular to each other. So they haven't written this in, but the square and the rectangle have right angles. We know that as a property. And so when we're multiplying, it's important that we multiply, dimensions that are perpendicular. Okay, I made that sound like a mouthful, but I'll show you what I mean. So in the very first question, if this was 3 and 4, to find the area of the square, we would just say base times height, or 4 times 3, although it actually doesn't really matter, 4 times 3, and we'd get 12, let's just say they're centimeters squared. Okay, so that's pretty easy. If in the height we had, let's say, a 3 here and a 7 here, the height doesn't even have to be the longest side. The height is just almost always the one that's facing perpendicular to the base. And again, area would just in this case be 3 times 7 or 7 times 3. Pretty, fairly straightforward. Now, when we get to the triangle, it gets a little bit more tricky, and I don't write divide by 2. What I do with the triangle is the formula I use is a half base times height. Base times height. And when we say height, this has to be at a right angle over here. So an example would be if this was, let's say, 8 and that was 4, then to find, let me get a different color, in order to find the area of the triangle, we go a half. The base is 8, so a half times 8, and the height is 4. And so my final answer would then be a half times 8 is 4, 4 times 4 is 16. So that's how we apply the formula. Now, it wouldn't have been wrong to say 8 times 4 divided by 2. That would give you the same answer, but often I find it's easier to write the half in front. I can go into, okay, for today, I'm not going to go into generating these formulas, but you can do that. For the trapezium, the one that looks like Table Mountain, you have what's called the two parallel sides. So the A and the B. And what we do is we add the A and B together. So let's actually give this some symbols. So let's make that 4, we'll make that 8, we'll make this 3. And let me get rid of this for the moment. So if we were applying this formula, the way it would look would be 4 plus 8 in a bracket. Okay, it's not wrong. We can divide by 2, always being timesing by the height. Okay, it says my internet connection is unstable. Can you hear me, Elzon? Elzon, can you hear me?
Yes, Peter, I can still hear you.
Okay, fantastic. And so in this question, we have 4 plus 8 is 12. 12 times 3 is 36. 36 divided by 2 is 18 centimeters squared. And then, actually, you know what? I'm not going to go through every single one of these, but basically these are the main ideas that we're going to be using as we find the areas. And the most important thing is that the base and height are always involved. If it's these first two, it's straightforward. If it's the triangle, there's a half in front. If it's a trapezium, you are going to just add the two parallel sides and divide by 2 and times by the height. And then the parallelogram is just the base times the perpendicular height. Okay, so we're not going to worry too much about these ones right now. So I know that was quick, but that was just meant to be a little warm up from class. If you feel like in class you never understood this, then you can definitely make some noise in the chat or, verbally, and we will adapt. But I will get a sense of what you know from this Kahoot. So we're going to play a Kahoot now. I'm going to try to open this up using my other account. So just give me a moment. And let's quickly, and then you guys are going to show me how much you know about this. So I'm going to press stop sharing this, and I'm going to share the Kahoot. I click play. I'm going to teach. We're going to play classic. Okay, now, for those of you at home who have not had the thrill of Kahoot before, stand by, because things are going to get real. So you need to go to www.kahoot.it, and you need to put that code in. And once you do that, your name will appear on the screen, and then you will show me what you know about area. If you need to, I would have the formulas on standby next to you, but see if you can remember them from the review I did now. Okay, welcome Awande. I love how we can just jump around in cyberspace. What a crazy world we live in. Okay, Sino, Ayabonga, welcome. Welcome to the Kahoot. Koketsu. Come on, everyone. Come and join the team.
This is gonna be fun.
It is. Things are going to get real. It's going to get competitive. I know. I know what students are like. Okay, so what I would sort of advise you is have a piece of paper and pen nearby so that you can do the calculations as we go. And then based on how this goes, then I'll know kind of how much detail to go in after that.
I will be
Okay, so the code I think is already in the chat. Okay, well, even if it's not, 303-2115. It'll stay on the screen, but I'm going to start us now. And so let the games begin, everyone.
2, 1.
Okay, how do we measure area?
Oh, goodness. How do you measure area?
Yeah, so for those who
It's
can't participate, you can put the color. So you can say like, for example, 1 blue or 1 green, if you think that's the answer. Okay, I'm about to bring the hammer down, so lock your answer in. 3, 2, 1. So when we measure area, we measure it in square units, or how many squares fit inside a shape. Okay, Gershom is on top. Oh, what happened there? Oh, it's at the top. There we go. There's no picture, but you do have the... So if one side of a square is 7 centimeters and the total area is 49, what is the missing side length? What are the properties of a square? Think about a square. Okay, I'm going to give you 10 more seconds, and then I'm going to hit the skip button. Lock your answers in now. Okay, so the answer is 7 because a square's dimensions are the same. So 7 times 7 would give you 49. So quite a few of you got it right, but if you didn't, just think about drawing a square and what that would look like. And if the one side was 7, the other side would also have to be 7 to get the area. Okay. Question 3. What is the area of this rectangle? Now you could count the blocks, 1, 2, 3, 4, but there's a quicker way. Okay, 5 seconds, and then I'm gonna move us on. Okay, it's gonna be well done, everyone. Well done. Nicely done. Oh, Alwande is on top, and some Kelo is on fire. Okay, I'm gonna go a little bit quicker now, unless the question is harder. So what is the area of this shape? I'm going to give you 20 seconds for this one. Okay, 5, 4, 3. Okay, lock in your answers. And again, okay, be careful here, guys. Let's just look at the picture. So this is still a rectangle. So if you look at the length that's 19 here and the breadth that's 8, you can't really count individual squares here. But what you need to know is that this means there's 19 columns and 8 rows. And so to figure out how many squares fit in here, you go 19 times 8. So maybe it's because you didn't have a calculator, but 10 times 8 is 80. 9 times 8 is 72. And if you add that together, you should get 152 square feet. Okay, so watch out for that. If you've got a rectangular shape, it's length times breadth, or the dimensions. Okay. Okay, so if you've got a rectangle, there's no picture. You've just got the side lengths of 6 and 8. What is the area of that rectangle going to be? Now think about it. Even if you have to draw a picture yourself, a rectangular picture. Okay, you got 5 seconds. 3, 2, 1. Okay, well done, everyone. You simply go 6 times 8. Oh, Latando's on the rise. So this time you've given the area inside, you've given one of the lengths. What is the missing length over here? What do I need for this to be 50 square meters? Okay, 3, 2, 1. Well done, guys. Well done. You're doing nicely. The only number it could be would be 10 times 5 to give me 50. Okay, we're going to go a little. I want to finish off in 2 minutes of this exercise. So similar type of exercise. See if you can do it. Okay, 8 times what gives you 32? Okay, 3, 2, 1. Okay, we are doing nicely. So it had to be 8 times 4 to give you 32. Okay, last three questions. And I'm only gonna give you 20 seconds for these ones now. What's the area of this rectangle? Three, 2, 1. You guys are on form. Let's get going. Okay, this is a little bit harder. What 2 lengths could a rectangle with an area of 30 square units have? So you have to choose the 2 lengths that would give you 30 square units from this question. Okay, I'll give you 5 more seconds. Oh, I see. The app does glitch sometimes if the Wi-Fi is funny. Okay, and the answer is, oh, you guys have got this. So the last question, before we go there, we see that Alwande is on top, Gershom is second, and Sino is third, but they're all pretty close together. And so for the podium, it's a true or false question. Multiplication is related to area, true or false. So if you think about the questions we've been doing so far, do you think it's related? 3, 2, 1. Okay. Time to move on, guys. You've shown mastery of this, and it's time to congratulate our winners. And the winners are, in third place, it's Sino. And our runners up were Lutando and Koketso. Well done, everyone. Okay, guys, I'm going to leave that Kahoot. I hope that that helped you to get, oh, where is it gone to? I need to turn it off. Where are you hiding, Kahoot? Okay, let me go back to sharing my screen so I can find it. Where have you gone? Maybe it's on the other thing. I'll find it, and there it is, and I can turn it off. Okay, fantastic. Back to OneNote. Okay, so for me, there's very little doubt that you understand how to do rectangular figures. But what if I now change it a little bit? What if I gave you these two shapes in the last lesson, but now you have to use some of your new knowledge? I want you to find the area of A and B, and I'm just going to give you one little hint. To find the area of a triangle, we go a half base times the height. And don't forget the theorem called the theorem of Pythagoras. It may become, actually, it may not be relevant here, but just in case. And I want you to get the answers for, we'll call this question A and this question B. And I want you to try and find the area of these two shapes using the knowledge that you've been thinking about and just extending it a little bit. So how would we find the area of these two shapes? Remember, we're interested in how much fits in here and how much fits in here, and also how much fits inside here. How can we work that out in an efficient way as we go? Now, the one thing I'm going to say is, wouldn't it be awesome? You don't have to do it like this, but part of me thinks it could be quite useful to do it like that. Or you could see this as one shape and then think what formula goes with that. And then for this one, maybe this will help you. So how do we find the area of that shape? Maybe that's giving you some hints. Okay, so answers are coming through already. So I'm going to use this method initially, and I'm going to say, well, the first one is 4 times 6. And then I know this is 3, and I know this is 4. So this could be a half, 3 times 4. And so that's going to be 24. And this is going to be 6, which is 30 centimeters squared. So that's the one way we could do it. The other way of doing it was to see the whole shape as a trapezium. Now, if we saw this whole thing as a trapezium, the way the trapezium formula worked was to say, in fact, I'll even just make it look like this, is we said the top parallel side, okay, it doesn't actually say it's parallel, but it sort of implies it, 6 plus 9, okay, divided by 2 times by the perpendicular height, which was 4. And you'll notice then that you get the same answer of 30 centimeters squared. Okay, then for B, well, for B, there are 5 squares, so we can go 5 times. And what's the area of a square? Well, it's just going to be 2.5 times 2.5. So let's see, 2.5 times 2.5 is 6.25 times by 5. We get 31.25 centimeters squared. So you know what? These two figures are about the same size. The one is 30 centimeters squared and the one is that, but they look very different. And it is possible for shapes to look very different, but still be, similar in size. Okay, so I think you guys are so good at this. It is time to move on. Let's see if I can, I have more questions there. Let's move on to the next one. Okay, now we haven't spoken about circles at all so far in terms of, and I'm going to first tell you what the area of a circle is, and then you're going to use it to work out these two questions. So it is a little bit of a weird one, but the area for a circle is pi r squared. It's a very famous theorem. And you may be asking yourself, well, what is that r in the formula? And the r is the radius. So if I have a circle and I stretch it out like that, all I need to know to find its area is the radius. But pi r squared means r times r. So another way of saying this formula is pi times r times r. And the way we actually get this formula, I'll just give you a little taste of it, is if you take lots of little pizza wedges and you stack them next to each other. Can you imagine like a little pizza where you were slicing out stuff? If you keep on doing that for smaller and smaller slices, it starts to look more and more like a rectangle. And a rectangle just has a length times breadth as its formula for the area. And so that is where the formula is coming from in terms of pi r times r. Pi r is just the one part and r is the other part. But for now, yeah, I'm not going to go into too much detail. Let's just kind of use it. So if I said to you, here's a circle and the radius is 5, then the area of that circle is just going to be pi times r squared or pi times 5 squared, which is just 25 pi, which is 25 times 3.14. So 25, 3.14, and we get 78.5 centimeters squared. Okay, now that's the basic idea, but this is different. In this question, we have a donut and we have almost like a thing. Now, in this case, I want you to try and use your thinking. How am I going to work out the area of the donut? And the only hint I'm going to say to you is think about two circles together. So we'll call this question 6a and 6b. Can you put answers for 6a and 6b in the chat? I see some people have already started to, but I just want you to think, how do I adapt this formula to find me just this area over here and just this area over here? I'll give you 2 minutes and I'm going to stop for my customary water break. And when I come back, I will look at the answers and see what you guys said. Oh. Okay. Imagine if you had a circle and someone stole the middle. How would you deal with that? Okay, I see some answers coming in. Okay. So I think a good way to do this is to say that a big circle minus a little circle. Okay, so that's the thinking I'm going to use in both of these. And we know what the area of, imagine that there was nothing bitten out of this thing. Imagine that the big thing has a radius of 12. And so its area is going to be pi 12, pi r squared, where the r is 12. But that would be incorrect because someone took a bite out of the middle. So we need to take away the area of the white circle or the non-shaded circle, and that part's radius is just going to be 7. So we have one big circle, and then we steal the bits in the middle and take it away, and that's why we subtract it. And using my calculator, that's going to give me 144 pi minus 49 pi. And so I'm getting 200. Okay, this one depends. Some of you, if you use 3.14, 3.142, or just straight old pi, it's going to be around approximately 298.45 centimeters squared. But anything around 300 means that you were doing this correctly. Okay, it would just be sometimes we use different values for pi. So you should get around 300. Okay, so if you didn't get that, I want you to think, how do you need to modify your approach for the next question, which is this one over here? Now, this is a similar type of problem. Okay, so you just need to think, what do I need to think about? Actually, let's think about this. The area of that circle is there. Actually, work out the area. Am I being, this second one it takes me a little bit more time to think about. Am I affected? I don't think so. So I know what the area of, yeah. So I still need even though it looks a bit strange, I need the area of the whole circle. And if I take away the circle that's inside it, I'm still going to get the shaded area that's left. So following the same logic as before, the big circle's radius is going to be pi 10 squared, and the smaller circle's radius is going to be 6. And so using that same logic, we should get, I say 100 pi because 10 times 10 is 100, and 100 times pi is 100 pi. Or you could also say it as 314.15 and so on, minus 36 pi. And you should get around 200. My calculator is saying 201.06 centimeters squared. 0.08 is fine as well. Okay, give me a thumbs up or thumbs down about curved shapes. Anyone? How are we feeling? Or give me a audio like yes, or give me a question. Okay. Okay, how about this one? Why don't you try and answer this one using what you remember from earlier on? This is area parallelograms. It's taken from the Watobe app. And I haven't spoken too much about this other than when I mentioned the formulas earlier. What is the area of this parallelogram going to be? And I want you to write your answer in the chat. Because this is it's not a rectangle, it's a parallelogram. So parallelograms actually have parallel sides, and they also have opposite sides that are equal too. But how does the formula for the area differ? Okay, there's one really important thing. We say the base is this thing over here, and the height is the perpendicular height here. So don't be multiplying by that 6 over there. Multiply by the 5. And so you're going to get 5 times 7, which is 35 centimeters squared. If you want to know why this works, imagine I took this bit and I chopped it off and I moved it all the way to over here. Can you see the shape that I'm going to get? I'm going to get a rectangle that has dimensions 5 and 7. And that's why we have to ignore the 6, because actually this shape of the parallelogram is the same as a rectangle where the triangle is just moved across like that. And that always helped me to understand why the formula for the area of a parallelogram is just base times perpendicular height. So that's actually not too bad a one. And I see most of us seem to have got that, so that's all good. Okay, now I'm not going to ask you to do all of these. I'm just going to ask you to do, which ones should I do? Okay, you're going to do 3 of them for me quickly. You are going to do number 1, number 2, and number 4. So I want you to do those questions. We're going to leave out 3 because I know that you can do that already. And we're sort of getting towards the end of the lesson today. And this is kind of bringing it all together. This is really building up for what we've done so far. These are called compound shapes because they combine different types of shapes. And I want you to find the area. So enough from me for now. I wait to see if you can extend the ideas from the lesson. All I'm going to say is think about breaking down the pieces. That might be a good hint. And then, yeah, once you got your answers, put them in the chat. Just remember, though, that this is not a rectangle. This is a compound shape. So we want to worry about that bit. And we also want to worry about that bit there. In this one, we want to worry about that. And that. So that's the thinking you should be using as we go through this. Question 1. So we're going to have the rectangle will just be 12 times 8. And for this, we're going to have, so it's pi r squared, but now it's half of that. So this is a little bit tricky. So for a full circle, it would be pi 4 squared because the radius is only going to be 4. It's halfway. And then I need to divide that by 2. Okay, so that's a little bit harder, but it's not, when you think about it, imagine getting the area of a full circle and then dividing that full circle in half. And so for question number 1, 16, there will be some rounding errors, but you should be getting around about 121.13 units squared. If you around that, feet squared. I can see a lot of you are in that ballpark, which is fantastic. If you only got 96, the only thing you left out was you left out the circle at the top. Okay, so that's all that went wrong. You just left out this bit over here. And so just remember, this is just a half circle. So find the area of a full circle and then just divide it by 2. Okay, let's go on to question 2 and question 4. Let's see if you can do those 2. And see what you can borrow from these. If this is 13, what does that tell me about the height of the triangle? It's maybe not a bad thing to think about. So this is going to be our exit ticket. This is the last questions for the day. So there's not going to be anything else after this. I think we've done well today. We've really moved through a lot of different areas. And in the next lesson, we can move into surface area and volume with a lot more confidence. Let's see what I can. So again, I think this is going to be two shapes. It's going to be the rectangle and the triangle. And so we're going to say 8 times 13. And that's not hard. What's a bit harder is, what is the height of this triangle? And I think that the height should be 6 inches, because if that's 13 and that's 19, that must be 6. And this must still be 8. So we go 1/2 times 8 times 6. And if my times tables serve me correctly, that's 48 divided by 2, or times 1/2 is 24. And this one over here, 8 times 13, oh, it's 80 plus 24, 104. And so you should get 128 feet squared, not centimeters, 128 feet squared. Ah, I see lots of you are getting that. Fantastic. Okay, last one for the day. Let's go out with a bang. This looks like something, you know, like a buoy in the sea, you know, one of those things that are floating around that you can kind of thing. Let's see if we can do this. So we first break down the two pieces. So it's a triangle and a half circle, or a semicircle. And then how do we find the area using that? Okay, so I'm waiting for some answers. Once you got your answer, if you could just pop it in the chat. Oh, I see we have lots of people today. It's so nice that you're all coming to join us. I'm so impressed by my diligent students. So first of all, for the triangle, I go 1/2 times by 8 times by 7, because I've got the base and I've got the height. Come back to that. Was there a question? I thought I heard something. Okay, and then for the semicircle, I must be careful, because can you see they've given me the diameter, not the radius? So because the formula for the area of a circle has radius in it, let me work out the radius right now. This radius is going to be 4. Oh, it's a bit thick. It's going to be 4. So a normal circle's area would be pi r squared, or pi 4 squared, but we don't have a normal circle. We've got half a circle. And so this whole thing is going to be divided by 2. And so we need to add those things together. So if we could just, people pop the answers into the chat there. So I think we're running out of time. So I'm going to, so 56 divided by 2 is 27, or sorry, 28. And then that plus 16 pi divided by 2. Did we all get 50? As long as I've typed this in correctly, we should have got 53.13 feet squared. Again, because of different values of pi, you might be around that. So you may not be exactly equal to that, unless I've made a, let me just check, because I feel something feels a bit off. So 16 times that divided by 2 plus 28 is around 53 feet squared. Yeah. Okay, so guys, we are going to call it a day for today, but well done. I think you've done really well. Alzana, I'm going to come back to you. Sorry, I've run a bit late. But yeah, coming back to you, and I'm stopping sharing my screen. And just really well done to all the students.
Awesome. I can't agree more. Guys, you really did such good jobs today. Well done for yeah, just
Such good
putting yourself
participation.
out there. Yes, yes. And it was very organized. So well done for you as well, Peter, for taking them from the one platform to the second or to the other platform. That was great.
I think I'm getting better at that. Smoother.
Exactly. Practice makes perfect. So I'm quickly going to share with you guys before load shedding hits me at 6. This is what you've done today and Monday. And like Peter said, this is a 4-lesson course on measurements. So well done. You've finished your measuring and calculating area topic today. Then on Monday, Peter, am I correct if I say it's working with volumes?
It is. We're also going to do something called surface area, but it kind of goes better with volumes because it's the surface area of 3D shapes. But it is volumes, but I'll add surface areas too.
Awesome. So I hope you guys got that. And then, as you know, the Watobe, I'm just quickly going to this before we do the leaderboard, just for in case. For revision work, it's going into Watobe's app. Then you'll see area and perimeter. And then Watobe, under that, you'll see comparing areas. Peter, this is the correct one, right?
Yeah, and also they can also do the one below that as well. So more perimeter and area of squares and rectangles. Both of those are good practice.
Awesome. Okay. So guys, it's this one and the one underneath. And then
okay. I think perhaps Alzan has been load shed. So I will finish this off for today. So yeah, thank you everyone. And if you could just give us a sense of how you're feeling about today. So let's light up the emojis. Are you feeling like in the middle? Are you feeling happy? Are you feeling like you're improving? Let's just have a sense of how the group is feeling. And also jump on the mic. Give us a little I know we didn't have much time for voices today, but if you're feeling brave, let us know how you're feeling on the mic. It's your time to shine. Okay, Oratile, I see those hands. Okay. And I see a couple of other thumbs up, which is great. Thank you so much, everyone. I really enjoyed today. I will see you next week. And yeah, keep the suggestions coming. If you think anything can be improved or you think that we could, it's always good to have a learning attitude. So I'm really open to feedback. And I will see you next week. Ciao for now.